Hello friends, welcome back. So, this is our third film and we hope that from the previous two films you have learned so many things. So now, I'm your host Vivek Desai and allow me to take you back to the world of engineering. So let's begin with what we are going to learn today. Okay, the subsurface investigation. Well, it's all about knowing what lies beneath the ground. The conditions vary site to site, but the foundation of the building is to be precisely designed for the condition of the soil at the proposed site. So an engineer cannot design a foundation without a thorough knowledge of subsurface investigation. In fact, the craftsman who built the Taj Mahal knew the issues of constructing it near a riverbank. An area of roughly 3 acres was evacuated, filled with dirt to reduce the seepage and leveled. The well foundation was designed keeping in mind the water level of Yamuna, whereas in today's scenario, demand of construction of structure is wherever land is available.
Nowadays, if you will consider the soil investigation cost, then as the price of land and material is raised to a great extent, now if you will consider the percentage of cost, it is very less, it is less than 0.5% of the total cost. And if you will consider the importance of the project, this value is absolutely negligible. So one should go for the soil investigation before constructing the structures.
So now let's move on to the important parameters that are needed to be investigated. Well, to make a foundation, we need to have so many data like density of the soil, the bearing capacity, where the water tables are, etc. Here we will see both the important parameters and the associated tests that are being done. Well, as we were discussed in our previous film, it all simply refers to the pressure that a soil can bear at the base of the foundation when the foundation fails in shear. To determine the bearing capacity, the commonly used field tests are the plate load bearing test, the cone penetration test and the standard penetration test. Well, the ultimate load of the plate is indicated by the break in the graph between load and settlement. Well, the advantage is that it can be used to determine the settlement of the foundation for the same load intensity. In some situations, when the quality of the undisturbed sample is unacceptable, well in those cases, the plate load test can be used. And Chatur has something to say about this. He has the disadvantages for the same.
Well, the disadvantages can be the time taken for this test and the procedure of digging up to the depth.
So next up, we have standard penetration test. Well, it is an in-situ test and very much famous amongst the geotechnical engineers. Origins of this test can be tracked back in 1920 as well. The test involved driving a standard split spoon sampler into a soil stratum at a required depth. A sampler is driven into a soil by a drop hammer which is standardized. Number of bores required for 300 mm penetration after the initial driven of 150 mm is SPTN.
The advantage is that it can give several parameters like relative density, the angle of internal resistance and the bearing capacity as well. It is a simple method which makes it famous as well.
So now let's move on to the cone penetration test. Well, these tests are being developed by the Dutch, so it is known as the Dutch cone penetration test. It is similar to the SPT and it has two types. The first one is static cone penetration test. Well, the second one being a dynamic cone penetration test, where instead of pushing it smoothly, one has to apply dynamic penetration, that is, the load applied by blows. Similar to the SPT, the number of standard blows are recorded and these are correlated to the properties. So now, our Chatur has some acknowledging advantages for it.
Well, this method helps in survey with wide area in the shorter time.
Well, our next subtopic is the shear strength of the soil. The shear strength of the soil is the maximum resistance that the shear stress can have just before its failure. Well, it should be understood that the failure of the soil occurs due to the relative movements of the particles and not by the breaking of the particles. Well, the interactions of the relative particles is what helps the soil to resist sliding or rolling past each other. So now, I'll hand it over to Chatur for some basic information relating to columns theory.
It also suggests the shear strength of the soil is dependent on the natural cohesive nature as well as stress acting on it. Well, the formula is so if the soil particles have more interparticle attraction or cohesion between them, the soil have more shear strength. And if we apply some additional normal stress on the soil mass, the shear strength is further enhanced.
Moving on to the direct shear test. Well, it is an easy test to determine the shear capacity of the soil. Soil is filled in a box called shear box, which is split into two halves along with the middle. Initially, the two halves of the box are held together by locking pins, and during the test, pins are removed and the shear stress is applied by pushing the top half of the box relative to the bottom half. Dial gauges are used to measure the vertical as well as the horizontal displacement. Finally, from the shear stresses and the shear strains, we get the shear strength parameters. And Chatur has some basic importance as well as the disadvantages of the direct shear test.
Well, the importance is, first, it is an easy method. Second, the bearing capacity can also be estimated using the formula. Third, it is very simple and cheap setup. Fourth and the last one is, the drainage condition can be varied as per the requirements. Well, the disadvantages are, only load at the failure is known. The failure plane here is horizontal, which may not be its actual orientation. And the soil is disturbed before testing, so natural condition of the soil is ignored.
Well, next up is a tri-axial test. Well, its origin can be traced back in USA, where the scientist Kalman used it to study the behavior of rocks. Cylindrical specimens are used for the test. In the first stage, called the consolidation stage, the specimens are subjected to an all-round confining pressure on the side, top and bottom. When the consolidation is completed, a deviator stress is applied at the top of the specimen so that it can be sheared. This second stage is called shearing stage. It consists of pushing a 4-blade vane in a soil and rotating it in a cylindrical surface in a soil failed by shear. A torque required to cause this failure is measured and converted to a unit shearing resistance of the surface. All the parameters like deviator stress, strain, pore pressure are being measured while the tests are going on. And the procedure is not as easy as you think it is. But trust me, it is a very beneficial test. And Chatur again has to say some advantages as well as some disadvantages for it.
The advantages are, it is an accurate method to find shear capacity. It resembles the field conditions. The soil is free to fail in the weakest plane. Precise measurement of pore pressure and volume change is possible. Complete control over the drainage conditions. And the state of stress in the specimen during any stage of the test is determined. And the disadvantages are, the equipments are costly and complicated.
Oh, this never-ending test will make us crazy. But never mind. The next one is a very interesting test, and it is none other than the vane shear test. It was originally used in Sweden in 1919 and used worldwide in 1940s, following further studies by the scientists like Carlson, Skempton, etc. So now it's turn of our very own virus to guide us with the advantages.
With the advantage is, it is the most appropriate method for the saturated clays of soft to the medium consistency. Imagine a soil sample which is too soft or with a very low shear strength to get it to the lab being undisturbed. This kind of soils cannot be used for the tri-axial test. It is useful for the soil which will not remain in a stable shape. In such cases, vane shear test is cheapest and the quickest method. Another example is the sensitivity can also be measured by this test.
Well people, we are done with all our tests. And now, the next up is the second parameter of subsurface investigation. The consolidation is a compression of a saturated soil under a steady static condition. Well, it is entirely due to the expulsion of water from the voids. Soil containing water is like a saturated sponge, and consolidation test is similar to squeezing the sponge. The procedure goes like the apparatus, also known as the odometer, consists of loading device and a cylindrical consolidation cell. Sample is placed in a ring with a porous stone on the top and the bottom sides. The ring is placed in an odometer and initial setting pressure is applied, followed by the gradual increase in the compression. The two most important soil parameters which we can get out of these tests are the coefficient of compressibility and the coefficient of consolidation. And both the parameters are going to help us to compute the settlement of structures. And all thanks to Sir Carl Terzaghi that we can now compute that how much time will it take in the settlement of new structures. Well, now it's the widest time to say the advantages about it.
Structures built on cohesive soils gradually sink with time, which is unnoticeable. If we are not going to perform this test, we won't know how much settlement is to be accepted while designing a structure. One of the troubles faced by the engineer is the structural instability due to settlement. So the objective of the test is to simulate the compression of the soil under expected external loads. And from the results, we can predict the settlement of various soil layers in the field.
The next property that we'll be looking into is the compaction characteristics of soil. Soil masses show different packing capacity or density at different water contents. We have seen people adding a little water to the soil before compacting it.
Suppose there is a huge road project involving crores of rupees and we have got to compact the soil before construction of the pavement. How much water do we add? Well, there is an optimum water content OMC which corresponds the maximum density of the soil. Well, this is what we found out by the Proctor compaction test. The test procedures consist of adding a known quantity of water to a soil mass and then compacting it into a standard cylindrical mold. Yes, everything including compacting efforts is standardized by the codes. The weight and the volume measurement give bulk density. The procedure is repeated for the different water contents. Our interest is in the graph between the dry density and the water content which gives the OMC. The OMC will be different for the different soils. Like for example, the range is 6 to 10 for the sands and 14 to 20 for the clays.
Well, another parameter that an engineer seeks is the permeability of soil. Well, it is the speed with which the water can move through a soil mass.
The equipment is simple. All we have got to do is to let the water pass through a standard specimen of the soil. The quantity of water that passes in some duration of the time is measured. The Darcy's law is also employed to get the permissibility of soil, which is usually expressed in cms.
And we have a virus for the types of tests we have.
Well, there are two types of tests. Constant head permeability tests for soils with large pore openings and variable tests for soils with small pore openings. It is important in calculation of seepage through earth dams, unbreakment of cannons, retaining walls, settlement of foundations, slope stability, etc.
Till now, we have been discussing about the engineering properties of soil, but there are several index properties too. These properties helps in soil classification and they have direct point to the engineering properties. Well, we'll not be looking at the detailed analysis of all the index properties in this session, but you'll be interested in seeing that what task we perform, what tests we perform in the lab.
One important index property is consistency limit or Atterberg limit. Alberg Atterberg was a Swedish soil scientist who worked in a ceramics industries in 19th century. They used to perform simple tests to describe plasticity of clay, which was important.
The liquid limit is a water content above which the soil will behave as a liquid. Well, it is found out in Casagrande's liquid limit apparatus or the Falcon test. Now the range of the liquid limit can be varied under 0 to 1000, but mostly it is less than 40. Well, another index property of soil is its particle size distribution. Size of the particles or their distribution have an effect on engineering behavior of the soil. Well, also for the classification purpose, we are interested in this particle size distribution.
So we go for an indirect method to quantify particle size distribution, and that is hydrometer method. The basis of this test is Stokes' law for falling spears in a viscous liquid. Grain diameter can be calculated from measurement of distance, time of fall, and density of the suspension. Well, there are other index properties too, like water contents and specific gravity. Water contents can be determined in the lab as well as on the field by several methods like own rank, epicnometers, alcohol method, radiation method, etc. Water contents of the soil mass can determine how it behaves and how much it weighs. So, keep that in mind.
Density is another important parameter, and we can measure density both in the lab as well as on the field. Now, the specific gravity bottle or the epicnometer can be used in the lab to measure the specific gravity of the soil solids.
The in situ density of the soil can be measured using the sand replacement method, core cutter method, rubber balloon method, etc. Basically, in this test, we remove some quantity of soil and weight it. The volume removed is then measured either directly or indirectly, like pouring sand into a pit and then measuring the volume occupied by the sand.
So guys, that's all for the day. I hope that you have thoroughly enjoyed our engineering films and have learned engineering in a fun way. I'm your host Vivek Desai signing off. Das Vidanya.